This is our lesson 5.4 quiz review. It's the third part. We're going to be looking at numbers 13 to 16. I know 17 and 18 fall under the same directions, but we are going to do that in the last video. So these are two different types of questions I have written here. So we are going to start with 12, 14, and 15. And 12, 14, and 15, it says there are logarithms on both sides of the equation. So looking at numbers 12, 14, and 15, you see that there are logarithms on both sides. And what we'll do, we'll always have the same base in these type questions. So if applicable, to condense the logarithms on each side to one logarithm. Number two, sorry, this equation got broken up. Use the fact that log, that should be base b of m, if log base b of m equals log base b of n, then the two arguments, m and n, have to be equal to each other. And then we'll solve the equation that's left over. So let's go ahead and look at 12, 14, and 15. So I'll zoom in a little bit since we're here at number 12 and 14. So number 12, step 1, it says, if applicable, condense each side. So let's look at the left side. Can we condense log base 3 of 2 minus log base 3 of x plus 10? And the answer is yes. We have a minus here, so our rules of logarithms, we would say log base 3 of 2 over x plus 10. So when it's subtraction, that changes to a single log, but divided into two arguments, equals log base 3 of 24. And now we're on to step 2. Use the fact that log base 3 of m, that if log base 3 of m, so here's, sorry, log base b, so here's our log base 3 of m, let's see if this works here, of this one, equals log base 3 of this, so that those two highlighted parts must be equal to each other. That's what that rule is saying. So we can just now say 2 over x plus 10 equals 24. And it says use techniques we previously learned to solve for the variable. Well, this is a rational equation. It has a variable in the denominator. So we multiply both sides by the least common denominator. We learned that back in lesson 5.2. Over on the left, this cancels. So we're just left with 2 on the left. On the right side, we distribute. We get 24x equals 200, or plus 240. And now we're solving for x. So that's a pretty simple equation to solve. Subtract 240 from both sides. 2 minus 240 is negative 238 equals 24x, and we divide both sides by 24, and we get, put it over here to the right, x equals, so we need to do negative 238 divided by 24 equals negative 9.9. Now, in the directions, I'll scroll up a tiny bit. It says round to the nearest hundredth. So that's 2 decimal places. So this is negative 9.92. Now, and if we put that back into our original, again, it would not equal exactly because we rounded, but it would be very, very, very close. So number 14. Same concept, that we're going to, if applicable, condense the logarithms. Well, on the left, we're adding logarithms with the same base. So that's the actually product rule. So log base 4 of 8 times x plus 6 equals log base 4 of 11 And now we're in step 2, where log base b of m, so log base 4 of, this is kind of like our m, equals log base 4 of n, then those two things that I just boxed in must be equal to each other. So 8. Now you could have distributed at the same time, but we'll just write it like this. Now we can distribute and solve. So 8x plus 48 equals 11. We'll go ahead and subtract 48 from both sides. So we have 8x equals negative 37, and divide both sides by 8. And we get negative 37 eighths. So negative 37 eighths, what's that? That is negative 4 and 5/8. And you can get what that's equal to. So we could just divide negative 37 divided by 8. So negative 4.6. And if we're following the directions, we will put 0.63, even though this one does come to a stop. Now, we do have to be careful. We talked before, not in length, but we talked that we cannot take the logarithm of a negative. I'm sorry, I wrote this wrong. That would have really thrown me off. It's negative 4.63. And so if we plug this back in for x, we got x as a negative answer, but we plug it back in, this would be a positive. And so as long as we're taking the log of a positive, we are okay. So negative 4.63 is our answer. And now we'll move to number 15. I don't know if we can fit this all on here. It's going to be kind of small. Number 15. Again, this fits what we've been talking about. There's logarithms on both sides. So we will go ahead and condense the left side. This is subtraction, so this is going to condense to log base 8 of x minus 1 over x is equal to log base 8 of 6. Now it fits step 2, so we know that x minus 1 over x equals 6. That's like our m is equal to n. And we have a rational equation. We want to multiply both sides by the least common denominator, which is just x. On the left side, it cancels. And so we're left with x minus 1 equals 6x. And we want to solve for x, so we get all the x's on one side. So I probably would just subtract x from both sides. And we get negative 1 is equal to 5x. Dividing both sides by 5, we get negative 1/5. And negative 1/5 equals negative 0.2. You could put it in your calculator, but 1/5 is 0.2. So there is our answer. Is it okay to put that back in our original? So let's put that back. Well, it's not, because then we would be taking the logarithm of a negative, and we can't take the logarithm of a negative. I'm just going back real quickly to make sure I didn't make any mistakes. And so we can't put that in there, so this is going to be a no solution. So again, if you go to plug it back in for x, and you're taking the logarithm of a negative, and that x there, we were saying is negative 0.2. We can't do log base 8 of negative 0.2. If you don't believe me, we can do like log of negative 0.2 divided by the log of 8. Oops, put in too many. Enter. error. All right. So actually, I'm going to stop that here, and then we'll do 11, 13, and 16 in our next video.